Math 1314, Tyler Junior College, Section 2.3, Linear Functions and Slope. Point-slope form of the equation of a line continued. In the previous video, we took an example and used it to build point-slope form, namely how to write the equation of a line if we know a point on the line and the slope of the line. Specifically, if the point is x1, y1 and the slope is m, then the equation of the line in point-slope form is y minus y1 equals m times the quantity x minus x1. In this next video, we're going to do another example using point-slope form. It's got a slightly different twist, but first, as I mentioned at the end of the previous video, here's the work for taking the last equation from the previous video and solving it for y. Distribute the fraction, which isn't that bad. You just got to multiply the two fractions by putting the 19 over 1. But then to solve for y, you have to add 71 to both sides. But in order to do that over here, we have to get a common denominator, put the 71 over 1, multiply both sides by 93 to get this, and then add the two fractions. And unless I made a mistake, which is possible, but unless I made a mistake, the previous equation solved for y is y equals 19/93 x plus 2,642 93rds. Did you try it? Did you get it? Did you get the same answer I got? If you didn't, go down in the comments and write something, unless the comments are turned off. All right, so let's move forward. All you need to make a line is 2 points. That's a geometry postulate that there's given any 2 points, any 2 distinct points, there's a unique line that passes through them. So it makes sense that we can describe a line by simply naming 2 points. So let's find the equation of the line that passes through the points 3, 6 and 9, 4. Now, we could sketch a picture of this, but we don't need to. It wouldn't be that hard. Plot the points and connect them. Well, what problem do we have if we're going to use point-slope form? Think of point-slope form as a recipe with 2 ingredients, a point and a slope. Do we have a point? Yeah, we have 2 of them. But do we have a slope? We do not. So we can't use point-slope form until we get a slope. All we have are 2 points. Do you know how to make a slope out of 2 points? You should. It was the first formula that we used earlier. If you have 2 points, you can calculate their slope. So the strategy here is before we use point-slope form, we must first calculate the slope. M equals fraction, subtraction on both sides. Which one do you want to call the first x? It doesn't matter which one. The 3, that's fine. But the minute you call him x1, everybody else has been named. x1, y1, x2, y2. Let's see what the slope is. Second y is 4, minus the first y is 6 in the denominator. Second x is 9, first x is 3. In the numerator we get -2. In the denominator we get 6. It'll stay negative, but it will reduce to -1/3. And again, it doesn't matter which order it doesn't matter who we called first point or second point. Had we switched them, the subtraction problems would have been backwards. The 2 would have been positive, but the 6 would have been negative, so the numbers would have been the same, and eventually it would have ended up being -1/3. So the choice of who is x1, y1, and x2, y2 is completely arbitrary. Now, let's set up point-slope form. Again, point-slope form is pretty straightforward. Since it's sitting right here, I'm not going to recopy it. I'll just fill it in. Y minus, we called y1 6, equals the slope, -1/3, times x minus, we called x1 3. Not too bad. But, wait a second. That's the point-slope form we would get if we had decided to call this point x1, y1. And I know why most people would decide it. It's the first point they read. But if I had written this one first, and this one second, it would have been the same line, and we would have called this one x1, y1. What would have happened had we done that? In other words, if we had, for whatever reason, called 9, 4 x1, y1, and 3, 6 x2, y2, either just because we're being contrary or because the points were written in the reverse order, what would have happened? Well, we already mentioned that the slope would have come out to be the same. If you don't believe me, recalculate it and go, hey, he's right. But the point-slope form wouldn't, because now it would be y minus y1, which we're calling 4. The slope is still negative 1/3, but x minus x1 would be x minus 9. And I think it's pretty obvious that these two equations are not the same. Look at them. I mean, they both have the same slope, but one of them has y minus 6 and the other one has y minus 4, whereas the other one has x minus 3 and the other one has x minus 9. So what's going on here? What does this mean? Well, what this means is for a given line, point-slope form is not unique. Because although the slope is unique for a given line, the point on it is not. A line has an infinite number of points. Any of its points would give you the correct equation. So it stands to reason that we can represent a line's equation in point-slope form multiple ways. In this case, it depends upon which point we call first and second. But are these equations really the same? They don't look the same yet. But we can make them look the same. How? Well, if we solve both of them for y, the left sides of the equations will be the same. They'll both say y equals. If these are truly the same equations, then the right sides should end up being the same as well. So why don't we solve both of these for y and see if they actually are the same equation? To solve for y, we'll first have to distribute. And even though the slope is a fraction, it's not going to be that bad because the numbers we're distributing to are multiples of 3. I did that on purpose. Negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 3. Well, negative times negative is positive. Multiplying by 1/3 or taking 1/3 of something is like dividing it by 3. So 3 divided by 3 is 1. And if we finish solving for y by adding 6 to both sides, we get y equals negative 1/3 x plus 7. Is that what we will get over here? I invite you to pause the video and solve this equation for y, if you haven't already. I hope we get the same result. Here I go. If we leave the left alone and distribute the negative 1/3 on the right, negative 1/3 times x is still negative 1/3 x. That's good. But negative 1/3 times negative 9, first off, is positive, and secondly, 1/3 of 9 is 3, which is not the same number we got here, except we're not done. Now we have to add 4 to both sides. Remember, we're solving for y, and we get y equals negative 1/3 x plus 7. So even though the 2-point slope form equations were different, when we solved both of them for y, they ended up being the same. Well, that's good because they should have been the same equation at some point. So these are no longer point-slope form. Point-slope form has y minus a number, it has a slope, and it's got x minus a number. And by the way, the minus numbers could become pluses if you subtract a negative. So what is this? Well, I know what the negative 1/3 is. It's still the slope, so this must be the slope. But what's the 7? Maybe if we graph this. How can we graph it? Well, oh, wait a minute. We have 2 points. I almost erased them. We can graph this pretty easily. Maybe not super accurately, but because I'm trying to figure out what the 7 is. 3, 6 over 3 up 6. You know what? For accuracy, I've got a yardstick. What a crazy idea. Let's measure things. Let's try this again. Okay. over 3, so we'll mark off 1 on each inch. 1, 2, 3, but we also need to go over 9. 4, 5, 6, 7, 8, 9. And we need to only need to go up 6 and up 4. So 1, 2, 3, 4, 5, 6. Okay, so 3 comma 6 is about here. And I don't have to about it, I can do this. 9 comma 4, there's up 4. So if we go over 9 and up 4, it's about here. So let's connect these and see what we get. I don't see any 7s, do you? Over here, 7 is at 1, 2, 3, 4, 5, 6, 7. Nothing exciting happened there. Up here we have 1, 2, 3, 4, 5, 6, 7. Maybe that's just, no, I measured it accurately. Is that 7 inches above? Let me see, come on. 1, 2, 3, 4, 5, it is. This point seems to be up 7, so as an ordered pair, it seems to be 0, 7. Seems to be the y-intercept. Oh, wait a second. If x is 0, then y is equal to 7. So that 7 does represent the y-intercept. So this equation contains the slope, and it contains the y-intercept. Guess what its name is? Well, I'll tell you at the beginning of the next video.